Okay, y'all, I'm recording this late at night from my house. So if my dog starts barking, sorry. Okay, trend lined equations, and this goes with the scatter plots. Um, in many situations, the equation of a trend line can be useful in making predictions, especially when predicting a value that you cannot see. This is going to be really important, guys. I've taken the test that you're going to be taking, and you're going to need to do some predictions. Okay. Remember that whole y equals mx plus b? Yeah, that's right here. The equation y equals mx plus b. Choose any 2 points on the trend line and set up a ratio of rise over run to find the slope. Remember the slope? This is not going away of the line or the m, okay? Look at the y-axis to find the y-intercept. Intercept of the line or the b. So then we're going to write the equation in y equals mx plus b. So here we go. Let's write some equations. So here's our trend line. We draw a line. This is the trend line, or another phrase you might hear is line of best fit. Line of best fit. Okay, I want to make sure you got those up there. Slope, y-intercept, mx plus b. Okay, so here is our trend line right here. So let's start here. We're starting on 8. So that's our plus 8. Okay, and let's go to another point. How about right here? We go down 1 over 3. So that's 1 over 3. It's negative. Put in our x. We did it. Okay. Let's go with this one. We're starting at 60. So put our plus 60. Okay. And then let's go to this point right here. We're going up 1 over, wait, oh, wait, we didn't go up 1. What did we do? We went up 20. Let's put that over here. Up 20 over 1, 2. Got to watch our numbers here. So that would be 10. 10x. Y equals 10x. Now, this formula, well, I'll show you in a minute. It's going to be important to have these formulas if they ask for a number that's like way out here. Like, let's say they want to know in 20. And so 20 is way out here and you can't really see where it's at. Well, you can plug in 20, 10 times 20 plus 60, and that will tell you when this line reaches 20. Okay. Again, you're going to have some outliers. You don't worry about those. That's an outlier. It's kind of outside of it. So let's do this last one. Watch for these numbers. These are going by ones, but these are not. So we start at 9. So that's our plus 9. And then we go, let's go to this pretty point. 1, 2, 1, 2 down. So that's the 2 on top. And then 5, 10 over. Is that right? 5, 10. Yeah. Okay, so then that would be 1/5. It's a negative slope, x, y equals. Okay, now practice writing and applying the equations, and this is where that prediction comes in. So first off, the scatter part below shows a number of items in a load of laundry. Here's the number of items. Here's how many minutes it takes to dry the laundry. Okay, or I'm sorry, it takes to fold the laundry. Okay, write the trend line or the line of best fit equation. Specify what each variable represents. Okay, so we're going to start at 0. So we don't have anything actually. Okay. And let's go to, let's go to here. This would be a good place to go because that's on the line. Okay. So we go 5, 10 up. So I put 10 on top. And then we go 5, 10, 15, 20. Okay. So every 10 minutes, you can fold 20 items. We can reduce that. So that can reduce to every, so y equals every 1 minute, you can fold 2 items. Okay. And there is no, the beginning is 0, 0. So then we just put an X. Okay. And that X is going to represent, what does that X represent? Oh, the number of items in a load of laundry, I guess. Yeah, that's what that represents. Okay. So use the equation to predict the time it would take to fold a load of laundry containing 60. So y equals 1/2 times 60. So it would take you 30 minutes. It took Joey 22 minutes to fold a load of laundry. So we're going to put the 22 is the y. See how we did that? And then we equal 1/2, and we don't know how many items. Okay? We don't know how many items. And so, wait, did I do that right? Yeah, we don't know how many items. So then you're going to multiply by 2, multiply by 2. So that would have been 44 items. Okay, let's go to the other side. Here's a scatter plot, right? Use the data to answer these. So let's first specify each variable represents in the context of this situation and write the trend line. Okay, so this is the number of drinks in several vending machines and the number of days since the vending machine was last stocked. Okay, so it started with 300. So there's 300. That is the start number. Okay. Then this is the number of days since it was last stocked. So when 1 day passed, we had this many left. 2 days passed, we had this many left. Do you see how that works? So let's go from this line, from 300 to right here. So we're going down 50, just 50. So 50 is on top. And then we're going over 1, 2, 3, 4. Okay. And 2 goes into both of those. So that would be 25 over 2. Yeah. So it goes down 25 drinks down. So it's a negative X. Down 25 drinks about every 2 days. Okay. Or you could say 12.5. You could also just do 12.5x and divide that by 2. 12.5x plus 300. So that's another way you could do it. Either of these is correct. Okay. Negative 12.5. Okay. Use the equation to predict the number of drinks a vending machine that was stocked 12 days ago. So let's use this equation. So we don't have to divide by 2. We don't have a fraction. So y equals 12.5 times, how many days did we say? 12 plus 300. Okay? I'm not doing that in my brain. My brain is too tired for that. So let's go to Desmos. And let's put it in the calculator. Shall we? We shall. Where did it go? Here it is. 12.5, 12, 300. 12.5, oops, times 12, and then plus 300. So the answer would be, oh no, this is negative, oops, negative 12.5. There we go. That didn't make sense that we had more drinks. See how I caught myself? So that would be 150. We would have 150 drinks left. 150 drinks. Okay. Now use the equation to predict the number of days since the vending machine was stocked if it only has 50 drinks. Again, this is the y. So 50 equals, let me put that negative there, negative 12.5x plus 300. Okay, so minus 300, minus 300. So then we have a negative 250 equals negative 12.5x. Again, I'm not doing this in my head. Negative 12.5 divided by negative 12.5. Let's go over here to Desmos. And I'm going 250 divided by negative, oh, that's a negative 250. Negative 250 divided by negative 12.5. So 20 days. My answer would be 20 days. Okay. And let's go on down here. We're almost done. Look at how fast we are. Julian made a scatter plot to show the number of band members at his school over the years. The trend line, the line of best fit of his scatter plot had this equation where Y represents the total number of band members. So this is the total number of band members. And X represents the number of years since this date. Okay. How many students would you expect to be members of the band in 2005? Okay, so first we have to go 2005 minus 1990. Okay, again, I'm not doing that in my head. So I'm going to go 2005 minus 1990. So that's 15 years. You probably did that in your head. I just don't worry my pretty head. Okay, so we're going to go y equals 6 times 15 plus 25. Y equals 6 times 15 plus 25. 6. Let me move this so you guys can see how I do this. You pull up, hold on, right here. 6 times 15. And then what was it? Plus, hey, try it again. 6 times 15. And then plus, was it 25? Plus 25. So plus 25. 118. Does that seem right? Yep. No, wait. 115 is what's on here. Did I do something wrong? Let's see. Let's look at this again. 6. Okay, did I do this right? 2005 minus 1990. 2005 minus 1990. Tell me if I made a mistake here, guys, because I got the different answer. So 6 times 15 plus 25. Oh, I said plus 28. There it is. Okay, so the answer is 115. Got it. Okay, see, I make mistakes too, guys. I make them all the time. You know that. 115 band members. Okay. Now, what about this? In what year would you expect the band to have 85 members? So we would go 85 equals 6x plus 25. So we minus 25. Let me kind of move it over here. So that would be 60 equals 6x. And then divide by 6, x equals 10. Now they're asking what year. So 10 years from 1990 would be, there goes my dog, 10 years from there would be 2000. 2000. There would be 85 members. Okay? That makes sense? Yeah, that totally makes sense. Let's do the last one. The scatter plot shows the elevation of several hikers compared to the number of minutes they've been hiking. Use the scatter plot and each statement is true or false. Okay, so several hikers compared to the number of minutes. So this is the elevation. They must be going downhill, right? Because as time passes, their elevation goes down. Right? So the trend line, let's see if that's right. We start at 900. Did we start at 900? No. No. That 900 would have been over here. That would have been over here. Now, this is supposed to be negative, but it starts here. They're going to ask us more questions about the trend line. So let's see where we're going. 100 down. And how many over? 1, 2, 3, 4, 5. Okay, so 5 into 100 would be 20. Is that right? Yeah. So 20x. That should be what it is. So those are the right numbers, but this is false. You could expect a hiker who's been hiking for 20 minutes to be at elevation 500 feet. Well, let's see. That would be 20 times 20 would be minus 400 plus 900 would we be at 500? That is true. This goes to this. Okay. You could expect a hiker at an elevation of 200. So here's our elevation to have spent 45 minutes hiking. Well, I don't know. Let's see. Negative 20x plus 900. Again, I'm not doing this math in my head. 900 minus 900. Well, that I can do. That would be 600, right? 700. So negative 20x equals negative 700. I keep saying the wrong. 700. So what is 700 divided by 20? So negative 700 divided by negative 20. And that's 35 minutes. So that would be false. That would be false because it would be 35 minutes, not that. Okay, that's it for today. You have some activities that you can choose from. There goes my dog. We finally made it to the end. Bye-bye.